In this video I'll be going through higher paper 1, non-calculator. Let's make a start. So the first question is, a graph shows maximum temperature and the number of hours of sunshine in 14 British towns in one day. None of the points is an outlier. Write down the coordinates of this point. So the point that's an outlier is the point that doesn't follow the normal pattern, so that will be this one. The coordinates of this point, so we can draw a line across horizontally and a line down using a ruler, and you end up with 10 there and 19 there. So it's along the corridor up the stairs, so that'll be a 10 and 19. For all the other points, write down the type of correlation, so you can see all the other points. You can draw a line of best fit through them, so that's a line that goes through as many points as possible. So that's that. So you can see it's a positive correlation. And if you can't remember if it's positive or negative, you can remember this rule here. So if the line goes down, it's negative, and you can do this. See, that forms an N, so it's negative. But if I did that here, that doesn't form an N, so that must be positive. On the same day, in another British town, the maximum temperature was 16.4 degrees. Estimate the number of hours of sunshine in this town. So, okay, the temperature was 16.4 degrees. Estimate the number of hours. So if you go over to a graph, 16.4 is roughly there. If I draw a line across to my line of best fit, yep, and then if I draw a line down from there, that looks to be like it's 12.8. If I scroll down, that is 12.8. The mark scheme accepts any answer in the range of 12 to 13. So as long as you put something in that range, you should be fine. A weatherman says the temperature is higher on days when there is more sunshine. Does the scatter graph support what the weatherman says? Give a reason for your answer. So he's saying the temperature is higher on days when there is more sunshine. So let's see, where is the higher temperature on the graph? So the highest temperature, if I was to highlight it, would be in this sort of range here. So these are the high temperatures. And that does support his claim, because if you look at this side, the temperature is high, and if you look at this side, the number of hours of sunshine is high as well. So the answer is going to be yes, but we're going to give a reason. Yes, because most points with higher temperature appear when there is more hours of sunshine. Moving on, so express 56 as a product of its prime factors. So 56, it's an even number, so we can just start with 2 and 28. That becomes 2 and 14, and that becomes 2 and 7. So the answer is 2 times 2 times 2 times 7, or you can write 2 cubed times 7. Next one, 56.4 times 4.3. What I like to do with these questions is get rid of the decimals. If I move the decimal out there, bit out there, we're now left with 546 times 43. So if we do that here, 546 times that by 43, we know 6 times 8 is 18. 4 times 3, 12, that's 13, 15, 16, 17. And then 4 times 6 is 24, 16, 17, 18. 4 times 5 is 20, that's 21, so that's 8, 7, and that's 8 plus 7, that should be 6 there. That'll be 14, that'll be 3, and that'll be 2. So now, because we hopped the decimal out twice, we're going to hop the decimal back in twice, so that's that, and then that there. So that then becomes 234.78 as the final answer. Moving on to the next one, the area of the square is ABCD is 10 centimeters squared. Show that x squared plus 6 is equal to 1. Now with squares, the base times height, the area is the base times height, and all sides in a square are the same. So the area is equal to 10, right? And we know the area of a square is the height times the width. So the height is here is x plus 3, that's the total height, and it's the exact same here, which is x plus 3. So the area is x plus 3, height times width, x plus 3 is equal to 10. We expand that, so we're going to multiply x by that, and that, and then we're going to do the same with 3 multiplied by that and that, so that then becomes x squared plus 3x plus 3x plus 9 is equal to 10, which becomes x squared plus 6x plus 9 is equal to 10. We can subtract 9 from each side, and you can already see that's looking the exact same as what we have in the question. So that's that there. This rectangle frame is made of 5 straight pieces of metal. Work out the weight of the metal is 1.5 kg per meter. Work out the total weight of the metal in the frame. So okay, it's a rectangle, so we know this side and this side are going to be the same. This side and this side are going to be the same, and then we're left with this bit in the middle that we need to work out. So we need to work out the total length of the metal used and then multiply that by 1.5. So we can see that it's a right angle triangle. So if I was to draw that out on the right here, that would look something like, oh, let me just draw that again, like that. There we go. That would look something like that. And this would be x, that is 5, and that is 12, and that's a right angle, so we can use Pythagoras theorem. So 12 squared plus 5 squared is equal to the longest length. That's 144 plus 25 is equal to x squared. That's 169 is equal to x squared. Square root both sides, so square root 169, and that gives me 13. So we can now add all the sides together. So that's 12 plus 12 plus 5 plus 5 plus 13 is equal to 47 meters. Now multiply 47 by 15 to work out the total weight, by 1.5, sorry. But just like before, I'm going to hop the decimal out, do the multiplication and bring the decimal back. So that's 5 times 7 is 35, 12, 13, 14, 15. That's 20, that's 23. That's 7, and that's 4, so that'll be 5. And that'll be 6, 7. So now I'm going to hop the decimal back in. So my answer will be 70.5, and I'll put that down here, 70.5. Now if I scroll to the next bit, the equation of line L1 is y is equal to 3x minus 2. The equation of line L2 is 3y minus 9x plus 5 is equal to 0. Show that these two lines are parallel. Okay, so the first things first, two things to bear in mind. The equation of a line is y is equal to mx plus c. So L1 is already in that form, which is y is equal to 3x minus 2. We want to write L2 in that same form, so I'll do that here. So we have 3y minus 9 x plus 5 is equal to 0. So that becomes 3y is equal to, we're going to move the 9 over, so it becomes a plus 9. We're going to move the 5 over, so it becomes negative. Now we can divide each side by 3 to get y on its own, so that'll be y is equal to 9 divided by 3 is 3, and then 5 divided by 3, we can just leave that as a fraction. So now this becomes y is equal to 3x minus 5 over 3. That should say 3 there. And now you can see the gradient in both lines is the same, so if I just highlight that, that, and that. So since the gradient in both lines is the same, so we can just write a statement here saying that gradient same for both lines, so they are parallel. Okay, parallel lines have the same gradient. There are 10 boys and 20 girls in a class. The class has a test. The mean mark for the class is 60. The mean mark for the girls is 54. Work out the mean mark for the boys. So just to bear in mind that the mean is the sum, so the total divided by n, which is how many there are. So for example, there's 10 boys and 10 girls, so that would be n. So we can start with looking at the girls. So always start with the information you have, and then that will lead you to the information you don't have. So let's start with any of these two. So let's start with girls. And let's look at the formula at the top there. So it's saying mean. For the mean for the girls, we know it's 54 is equal to the total. We don't know what the total is, but we don't know how many girls there are. There's 20. So we know that the total for girls is equal to 54 times 20, we can do that here. 54 times 20, that's 0, 0, that's 8, and that's 5 times 2 is 10, so that becomes 1080, so that is 1080. I'm just going to draw a straight line down. We can now look at the total for the class here. So the class is, the mean for the class is 60. The total for the class we don't know, but we know in the class altogether there's boys and girls, so there's 30. So that means the total for the class is equal to 60 times 30, which is 1800. So now we know the total for the class, girls, and we know the total for the class. Let's now move on to the last bit. So we now have boys to look at. So that for boys, the mean is, that's what we need to figure out for the question. That's what the question is asking for. What is the total for the boys? We don't know. How many boys are there? 10. Can we work out the total for the boys? Yes, we can, because we know the total for the class was 1800. We know the total for the girls is 1080. So the total for the boys must be 1800 minus 1080 is going to be 720 for the boys. So we can write mean is equal to 720 divided by 10, which is equal to 72. So the mean mark for the boys is 72. Next question. Write 7.97 times 10 to the minus 6 as an ordinary number. So that becomes, let me just write that out, that's 7.97 times 10 to the power of minus 6. So all the minus 6 they're saying is hop the decimal to the left 6 times because it's negative. So to the left, 1, 2, 3, 4, 5, 6. So that becomes, decimal goes there, so that's 1, 2, 3, 4, 5, 0. So the answer is 0.123457797. Look at the value of 2.52 times 10 to the power of 5 divided by 4 times 10 to the minus 3. Okay, right, let's write this out as a fraction. So that's 2.52 times 10 to the power of 5. And we're dividing that by 4 times 10 to the minus 3. So let's take care of the indices first. So that's this left side here. We know when you divide indices, it's the same as taking them away. So this will become 5, take away, minus 3, which becomes 8, because the minus and the minus become a plus. So now this becomes 2.52 divided by 4 times 10 to the power of 8. Now let's deal with the left-hand side, which is this here. So remember what I said earlier, instead of doing 2.52 divided by 4, let's hop the decimal out, do the division and hop the decimal back in. So that then becomes 4 divided by 252, 4 goes into 25 6 times, with a remainder of 1, 63 is the answer. So this then becomes 63, but we're going to hop the decimal back in, so that's going to be 1, 2, so that becomes 0.63. So now we're going to go back over here, so that's 0.63 times 10 to the power of 8, but the question says give your answer in standard form. So we're going to hop the decimal 1 to the right. Because we're hopping it 1 to the right, it becomes 6.3 times 10 to the power of 7. That's 6.3 times 10 to the power of 7. Jules buys a washing machine. 20% VAT is added to the price of the washing machine. Jules then pays a total of £600. So 20% VAT is added to the price. He then pays a total of 600. What was the price with no VAT? Okay, so we're told 20% VAT is added. So the price of something usually is 100%. They've added 20%. So he's paid 120%. So that means 120% is equal to the £600 that he paid. So we need to find out with no VAT. So with no VAT, that's going to be 100%. So we're going to go, we need to essentially go to 100%. But what we'll first do is go to 1%. So divide each side by 120. 120. So that's 600 divided by 120. We can cancel the zeros out. So we're left with 60 divided by 12. So that's going to be 5. But if 1% is 5, then to go to 100% times it by 100. So that then becomes 500. So that is 500. Next question. Show that x plus 1, x plus 2, x plus 3 can be written in the form ax cubed plus bx squared plus cx plus d. So Let's write out the brackets, so that's that. Now I like to work from left to right, so we're going to expand the brackets on the left first, so that's going to be this x times this x, so that's x squared, plus the first x times the 2, so that's 2x, plus 1x, plus this times this, which is 3. I'm going to put that in brackets, and that's going to be x plus 3. So we can collect these two like terms, so that becomes x squared plus 3x plus 3. That will become x plus 3 still. And now we're going to do the exact same thing, but this time there's 3 terms to multiply. So we're going to multiply x squared by everything in the bracket on the right. So that's going to be x squared times x. So that's x cubed. So I've done that times that. Now I'm going to do x squared times 3x. So that's 3x squared. Now I'm going to do this one, which is going to be 3x times x, which is 3x squared, plus 3x times 3, which is 9x, plus 3x plus 9. Now I'm going to collect all the like terms, so I can see there's only one x squared, so that I can write as, 1x cubed, so there's x cubed there. I can see there is 2, let me just choose a different colour, there's 2 of these x squared terms, so that becomes 6x squared. You can see there's a 9 plus 3, which is 12x, plus 9. I think I have made a mistake with this one. I'm just checking it against the final answer and it doesn't seem to be right, so maybe I've gone wrong. X squared plus 2x plus x plus, oh, that should be a 2, my bad. I'm just going to rub that out and that out, so that becomes 2, that's 2, so then that will change some of the stuff here, so I'm just going to take this out, so that then becomes x cubed plus 3x squared plus 3x squared plus 9x plus 2x plus 6. So just do that again, so we can collect these two together, so that's going to be x cubed plus 6x squared plus 11x plus 6. Moving on, the graph of y is equal to f of x is drawn on the grid, and write down the coordinates for the turning point of the graph. So the turning point is the point where the graph turns, so that is right there. So we can see the coordinates for that are, if we just draw a line down, it's going to be 1, I've drawn that a little bit bent, but it's going to be 1 and minus 3, so that's 1, along the corridor, down the stairs. Write down the estimates for the roots of y is equal to f of x. So there's 2 hints in this question. One is estimates, so that means there must be 2 answers. And the second one, if you look up here, we have this equation. The graph is y is equal to f of x. So if I copy that equation down here, y is equal to f of x. We've been told f of x is equal to 0, so that means y is equal to 0. So go on here, find the y-axis, which is that one, go to 0, which is right there, and now draw a line across. So that means this point here and this point here. So write down the coordinates of them 2 points. So that is going to be, the roots are going to be where it crosses the y-axis, the x-axis, so that is 2.75, and minus 0.75. The mark scheme accepts any answer in the range 2.8 to 2.7, and then minus 0.7 to minus 0.8. So as long as you're in that range, that's fine. But for this one, it's the correct answer only, so you must get that. Use the graph to find the estimates for y is equal to f bracket 1.5. So again, if I go back to this equation that I had up here, so that's basically saying y is equal to f bracket 1.5. So now we need to find y. So we look at the x-axis where x is 1.5. So if I go back up to my graph, x is 1.5 right here. If I draw a line right down, it nicely hits that point, which is 2.8, minus 2.8 on this side. So the answer to that is minus 2.8, and it's correct answer only, there's no range allowed. So moving on to question 12, we now have 81 to the power of minus a half. Whenever there's negative powers, it just means 1 over. So we can write it as 1 over 81 to the power of a half. Now the negative's gone. That's the same as 1 over root 81, which is 1 over 9. Next one, 64 over 125 to the power of 2/3. So the number at the bottom, the number at the top is the power, the number at the bottom is the root, so that would be 63. We can write that as 63 1/3 over 125 1/3 square the top, square the bottom, which is the same as the cube root of 64 over the cube root of 125, and then we're squaring the answer. So the cube root of 64 is 4. We're going to keep the square there. The cube root of 125 is 5. We're going to keep the square there, so that's 16 over 25. Moving on, the table shows a set of values for x and y. Y is inversely proportional to the square of x. All that means is y is inversely proportional to the square of x. We can just write that as that. Find the equation for y in terms of x. So that means y is equal to something when it says y in terms of x. So they've told us it's inversely proportional, so we can use the constant of proportionality, and that becomes y is equal to k over x squared. Now all we need to do is sub in some coordinates to find out what k is. So if I look across the table, these coordinates look nice because x is 1 and y is 9. So if I sub them coordinates in, so when y is 9, x is 1, so that's the same as saying k is equal to 9. So find an equation for y in terms of x, so that is y is equal to 9 over x squared. There's my equation. Next question, find the positive value of x when y is 16. So again, if we use that equation that we found up here, that then becomes 16 is equal to 9 over x squared, which we can do a bit of rearranging. That means x is equal to 9 over 16, which can then be written as x, so I'm just going to draw an arrow there, x is equal to root 9 over 16, and we can write that as root 9 over root 16, which is 3 over 4. Question 14. White shapes and black shapes are used in a game. Some shapes are circles, some shapes are squares. The ratio of the number of white shapes to the number of black shapes is 3 to 7. The ratio of the number of white circles to white squares is 4 to 5. And the number of black circles to the number of black squares is 2 to 5. Work out the fraction of all the shapes. All shapes are circle. Okay, work out what fraction of all are circles. Right, so straight away we know this. I'm just going to write that up here. There's some black shapes, there's some white shapes, right? There's some black circles and some black squares. There's some white circles and there's some white squares. And the question is asking us for circles. So how many are white circles and how many are black circles? So let's start with looking at the black shapes. So if I just write black here, right, so the probability of it being black is equal to, well, in total this is out of 10, so there's going to be 7 out of 10. That's where I got the 7 from, and the total is 10, 3 plus 7. What's the probability of it being, how many, okay, so we have black circles, the ratio, yeah, black circles, there are 2 out of 7, so I've got that from here. So 2 out of 7 are black circles. So now I just need to multiply the 2 together to figure out, because I know 7 out of 10 are black, and out of them 7 out of 10, only 2 out of 7 are circles. So if I do 7 out of 10 times 2 out of 7, that tells me how many of the total are black circles. So that'll be, we can do a little bit of cancelling out here. There's a 7 there, we can cancel that out. And that becomes 2 over 10. You don't have to, you can multiply all across. It'll simplify to the exact same thing. Now that we've looked at black, we'll do the exact same for white. So what's the probability of it being white? So that's going to be that there. So that's 3 out of 10. And then what's the probability of it being a circle? So that's white circle, so that's going to be out of 9, 4 out of 9. Now we're going to multiply the two together to figure out how many in total of the white are circled. So that's 3 out of 10 times 4 out of 9. Again, we can do a bit of cancellation here. So that becomes 1, that becomes 3, so that becomes 4 over 30. And now if I come down here, that now becomes, to work out the fraction of all shapes that are circles, so that'll be this number plus this number, so that'll be 1 over 5 plus 4 over 30. I can make the denominators the same by multiplying this side by 6 and 6, so that becomes 6 over 30 plus 4 over 30, which becomes 10 over 30, which becomes 1/3. The cone has a volume of 98 centimeters cubed. The radius of the cone is 5.13 centimeters. Work out an estimate for the height of the cone. Thankfully, they've given us the equation for the volume of a cone, which is right there. So, if I write that equation out, volume is equal to 1/3 pi r squared h. So the volume is saying work out an estimate, so we're going to make our life a bit easier and make these numbers easier for us. So the 98 can become 100, it's an easy number to work with, so that's 1/3 times pi can become 3 because we're estimating. The radius can become 5 because it'll make our life easier, so then we're left with 100 is equal to 1/3 times 3, so these two just cancel out, and then that becomes 5 squared, which is 25 height, and if I divide each side by 25, that then becomes 100 over 25 is equal to height, which is 4 is equal to the height. Now it says John uses a calculator to work out the height of the cone to 2 decimal places. Will your estimate be more than John's answer or less than John's answer? So if you look at what we've done, we've actually increased the value of the number on the right. That's gone up to 100. And on the left, we've rounded down. So we've rounded pi down and we've rounded radius down. So this value has gone down. So we've made the numerator higher and we've made the denominator lower. So that then means our answer is going to be more. And then you can just say, because we've increased the numerator and numerator goes up and the denominator goes down. That will do. And is an integer greater than 1, prove algebraically that this is always a positive number. So a little hint here, whenever you're given something like this, always expand it out. So even if you don't know where to start, so that's going to be n minus 2, n minus 2. Let's expand that out. So that's n squared minus 2 minus, keep the brackets in, so that'll be n squared minus 2n plus 4. You can collect these two like terms, so that becomes n squared minus 4n plus 4. Let me copy this in. And now we can multiply it all by this negative to expand the brackets out, so that's n squared minus 2 minus n squared plus 4n minus 4. And then these two cancel out, so then that becomes, I can collect these two like terms, so that's that one there and that one there, so that then becomes 4n minus 6, and I can factorize that into being 2 bracket 2n minus 3. Now, whatever number you multiply by 2 becomes even. So if you multiply 11 by 2, it becomes 22. If you multiply 7 by 2, it becomes 14, for example. So since it's a multiple of 2, it doesn't matter what value you put in. The answer will always be even. There are 9 counters in a bag. 7 of the counters are green, 2 of the counters are blue. Ria picks 2 counters from the bag. Work out the probability that Ria takes 1 counter. This bit is key. 1 counter of each color. Okay, looks like you can draw a tree diagram for this. So line there, and a nice straight line there. So there's green and there's blue. So the probability that she takes a green is 7 out of 9. So you can see that total is 9. The probability that she takes a blue is 2 out of 9. So this is the first pick. And then once she's done the first pick, you just write that there. That's green. That's blue. And that's going to be green. Okay, if she's picked a green the first time, if you look up here, if she's picked a green the first time, that means there's one less green in the bag now, so that'll be 6 out of, and the total's also gone down, the total's no longer 9, it's going to be 8. And then blue will remain the same because she picked a green the first time, so that'll be 2 out of 8. And then if you look down here, if she picked a blue the first time, there's one less blue in the bag now, so there's only one left, and the total's gone down by 1, but the greens remain the same, and the total still goes down by 1. So your answer is one counter of each colour, so she's either picked a green and then a blue, or she's picked a blue and then a green. So we're going to do 7 over 9 times 2 over 8, which is 72 and 14, or it's going to be 2 over 9 times 7 over 8, which is, again, 14 over 72. And then we're going to add these two together, because you could have taken either root, so that'll be 14 over 72 plus 14 over 72, which becomes 28 over 72, which can be simplified to 14 over 36, which then becomes 7 over 18. Moving on to the next one, A, B, C, D is a rhombus. The coordinates of A are 5, 11. The equation of the diagonal DB is y is equal to a half x plus 6. Find an equation for the diagonal AC. So let's draw some stuff on. So if they've told us the coordinates of A are 5 over 11, so let's draw that on. So this is 5, 11 are the coordinates here. The equation of the diagonal DB, so D to B we've been told is a diagonal, and the equation is y is equal to a half x plus 6, and then it's saying find an equation of the diagonal AC, so I'll just use a blue line for that. Okay, so one thing you need to remember is they're both diagonals, DB and AC, that means they both cross each other at 90 degrees. So find the equation of the diagonal AC. Again, always start with the information you have. So in this question, we've got two lines. One is line DB, so that's line DB, and then we on the left or right here, line AC, and that's what we need to find the equation of. So let's start with what we have, which is y is equal to a half x plus 6. Now, because both these lines are diagonal, there's a rule that you need to remember, which is when two lines are diagonal, we can work out the gradient using this formula where m1 times m2, which is line 2, is equal to minus 1. So this is the same as saying the gradient of line DB times the gradient of line AC is equal to minus 1. So we know the gradient of line DB is a half x, because remember the equation of a straight line is y is equal to mx plus c. So m is a half. So we can put it into that equation, so we'll do that down here. So that will be m dB times MAC is equal to minus 1, which is a half, times MAC is equal to minus 1. Now, I can move the 2 over to that side, times each side by a half, so that becomes, times each side by 2, so that then becomes MAC is equal to minus 2. And that also looks right. You can always sense check your answers. If you look at this graph here, if I just grab my pointer, you can see that this line has a positive gradient of a half, and this line must have a negative gradient because it's going down, and it's going down a lot steeper, so the gradient will be higher. So that looks sensible. So always sense check your answers as well. So now I know what the gradient of this line is. If I now come over to this line, the question's asking me for the equation. So y is equal to mx plus c. I now know the gradient, so that is y is equal to minus 2x plus c. What else do I know about the line AC? Well, if I look at my graph, I know there's 2 points that the line passes through, and that's these two here. That's 5, 11. So now if I come down here and I sub them coordinates in, so 11 is equal to minus 2 times 5 plus c. So that is 11 is equal to minus 10 plus c. If I add 10 to each side, that becomes 21 is equal to c. So my final equation then becomes y is equal to minus 2x plus 21. 19. OABC is a parallelogram. OA is A, OC is C. X is a midpoint on the line AC. Let's draw that on. So we have this line A to C, where it has a midpoint of X. OCD is a straight line. So D is not actually drawn on here at the minute, but it's saying O to C to D is a straight line. So let's just imagine D is some point down here, because it's told me it's a straight line, so that's D. And it's told me O to C, C to D is K to 1. Given that X to D is 3C minus a half A, find the value of K. Okay, so essentially what I need to find the value of K is this bit here. So I know what O to C is, which is K, and they've told me this, it needs to be in this ratio K to 1. I need to know what the vector of this line is. I know the vector of this line is C. I need to know what the vector here is. That's what I need to find. C to D is what I need to find. So how do we go about doing this? So what has the question given us? It's given us X to D. So we know that if you write it out as vectors, X to D is the same as going from X to C plus C to D. Now, I need to know two of these to find this one out. That's what I need to find out. I know what this one is, so I'll put a tick there. I need to find what X to C is. Can I find what X to C is? Well, I know what A to X is a midpoint. Whenever you're given a midpoint, a top tip, you can always find the full length of the line. So for example, this is a midpoint here. I can find the vector for the full line and half it. So let's go about doing that, and you'll see how some things start appearing in front. So A to C, how do I go from A to C? Well, that's going to be minus A plus C, right? So what's A to X going to be? Well, A to X is equal to X to C because it's a midpoint. Well, I know that A to X, or in this case, we're interested in X to C, but they're both the same, right? It's going to be a half of A to C because it's a midpoint, so it's going to be a half of this. So all of a sudden, I've now found what this is. And now all I need to do is take away this, and that will tell me what that is. So now if I keep going down here, and I'll just draw a line through there to separate the two out, and I come here, I can write 3C minus a half A. I'm just writing this down here, which is X to D, is equal to X to C, which I've now found. I'm just going to expand that, so that's going to be minus a half A plus a half C, and I've gotten that from here. And then that's plus C to D. That's what I need to know. So now, if you look at this, if I add a half A to each side of the equation, that wipes this out. So if I add half A here to move this over, that goes and that goes. And now we're left with this, a half C and 3C. Well, you know 3 minus a half is 2.5, so we can write that as 5 over 2C is equal to C to D. Now all of a sudden, we know what C to D is. So if I now come back up here, we know that this vector from C to D, let me just draw that on, is going to be 5 over 2C. So now do I know how to find K? Well, how do I go from 5 over 2C to 1? I'm going to divide it by 2 over 5. So how do I go from C to there? I'm going to divide it by 2 over 5. And then that becomes K is equal to 2 over 5. And if hopefully that made sense, and if it didn't, I'll draw it out again here. So that's a straight line. That's O, that's C, and that's D. And they've told us the vector for this bit here is C. I've found the vector for this bit here to be 5 over 2C. And in the question they told us O to C is K, and this is 1. That's the ratio they want it in. So they're saying when this is 1, what is K? So how do I go from 2.5, 5.5 over 2 is the same as 2.5. So how do I go from 2.5 to 1? Well, I can divide this side by 5 over 2, and I can divide this side by 5 over 2. I'll put a C in as well. So if you do C divided by 5 over 2C, now KCF, so that'll be C times 2 over 5. C, and that C will then go down here. That becomes 2/5. So that is how you get K. Solve algebraically the simultaneous equation x squared plus y squared is equal to 25 and y minus 3x is equal to 13. So in this case, you normally want to substitute something into this equation and you want to rearrange this equation. So let's write that down here. So we have x squared plus y squared is equal to 25. And then the equation at the bottom we can write as y is equal to 3x plus 13. I've just rearranged that so it's in the form y is equal to mx plus c. It doesn't need to be in that form, but we just want y or x on one side. So actually you can ignore that. You could rearrange it for x or y, it'll work either way. Now I need to substitute y into the equation above. So that will now be x squared plus 3x plus 13. So I'm substituting it into y, which is squared. So I'm going to write that as 3x plus 13 is equal to 25. Now I'm going to expand that equation out, so that now becomes x squared plus 169, that's 13 times 13. You can do it in any order, and then that's 78x plus 9x squared is equal to 25. So now that becomes, you can collect the like terms, so that and that can be collected, so that's 10x squared plus 78x plus 169 is equal to 25. Now we can take away 25 from each end, so that then becomes, let me just cross that out, that becomes 10x squared plus 78x plus 144 is equal to 0. And now we just need to solve this equation. It looks like quite a difficult one, and because all the numbers are even, we can divide each side by 2, so 5x squared plus 39x plus 72 is equal to 0. Right, so now we need two numbers that multiply together to give us, so 5 times 72 is 360. So I've multiplied this number and this number together, and that's given me 360. And I now need two numbers that multiply to give 360, that add or subtract to give 39. Now you can start with 2, so that'll be 2 times 180, and then you'd carry on going, and you'll find the two numbers that work are 15 and 24. So I can write this as 5x squared plus, it is quite a difficult question, this one, in terms of finding them two numbers, plus 72 is equal to 0, and now I can factorize this, so that'll be 5 bracket x plus 3, copy the x plus 3 here, so that'll be 24 there, so that'll be 24x plus 72 if you expand that. So this now becomes 5 plus 20 missed the x there, so that becomes 5x plus 24, and then that becomes x plus 3 is equal to 0. And in order to make this equation 0, x is either equal minus 3 there, or x is going to equal minus 24 over 5 here. Now we're going to sub this back into this equation all the way up here, so this equation that we arranged earlier, to get what y is. So I'm going to copy that equation down, so we have y is equal to 3x minus 13. I'll start by subbing in x is equal to minus 3, so that'll be y, 3 bracket minus 3 minus 13, so that'll be 3 times minus 3 is minus 9, and then it'll be minus 9 plus 13, sorry I copied that down wrong, minus 9 plus 13, so y is equal to 9 minus 9 plus 13, which means y is equal to 4. And then I'll do the exact same for minus 24 over 5, so that is y is equal to 3 bracket minus 24 over 5 plus 13, and then that becomes y is equal to minus 72 over 5 plus 13, and then you can times the top and bottom by 5 on this side, and then you'll end up with minus 7 over 5. ABCD is a quadrilateral, AB is equal to CD, ABC, angle ABC is equal to angle BCD, prove that AC is equal to BD. So one of the things you want to spot with this question is the fact that AC, BD, so AC can be drawn like this, right? And it's actually a full triangle like that. And that's a triangle. And then if I did B to D, that is also a triangle there. Now both of these triangles share the same side, so both triangle ABC and BCD share side BC, so they both share the same side, and you can see with these two lines here that this side and this side are the same. BA and CD are equal, and then the angle between them are both the same, so the angle ABC is equal to the angle BCD. So we have side, angle, side, because we have this side and this side are the same, and then this angle and this angle are the same. So two sides and an angle are the same. So AC is equal to BD. The diagram shows a hexagon ABCDEF. ABC, ABEF, CBED are congruent parallelograms where AB is equal to BC is equal to X centimeters. So with questions like this, always start by writing down, or drawing on, I should say, as much as you can. So we've been told AB is equal to BC, which is X. So this is X, and this is X as well. P is a point on AF, and Q is a point on CD, such that PB and BQ are 10. So P to B, actually I'll use a different color for this. So that to that, and then that to that. That's 10, and that's 10. Given the angle ABC, so that's the angle, I'm not going to draw that in, but I'll label it here, that the angle ABC is equal to 30 degrees. Okay, prove that cos PBQ is equal to 1 minus 2 root 3x squared over 200. So just by looking at that proof there, there's two interesting things or hints that you can notice. The fact that they've mentioned this angle, cos PBQ, that's interesting that they mentioned that. So that's going to be a point of interest for us. And the second thing is hopefully realize that at some point we'll be using the cosine rules, which goes something like a squared is equal to b squared plus c squared minus 2bc cos A. And I can figure that all out by just looking at what they've asked us to prove. So if I now go back and look at my diagram in terms of what I've drawn, so let's individually draw what we know. So we know we have A, B and C. So we have A, we have B, and we have C. Okay, we know that this side is X, we know that this side is X, and we know that this angle is 30. Okay, and then the other thing they've told us about is PBQ. So again, all I'm doing here is drawing out what they've actually given us. So that's, I just draw a straight line up. Let's go this way a bit. 9 there. So that's P, that's B, and that's Q. And they've told me that this is 10 and this is 10. Okay, and I know that the question's interested in the cos PBQ, so I never need to figure this angle out because in the proof it's never figured out. But one thing hopefully you've also noticed that's interesting between these two that look almost like triangles is that this length here, A to C, is the exact same as this length here, P to Q. So if we use a different color to draw this on, this length in dark blue is the exact same as this length here. So I'm going to call this angle A, looking at my equation down here, because that's cos BBQ. This must be A, this must be B, and this could be C. So now let's just look at PBQ and sub that into this equation. So that's A squared, which we can leave as A squared. That's B squared, which is 10 squared, C squared, which is 10 squared, minus 2BC, B is 10, C is 10, cos PBQ. We know the question's not interested in that because that's how it's given in the proof. So now if you simplify that, we have A squared is equal to 10 squared plus 10 squared, so that's 200, minus 2 times 10 times 10, that's 200, and that's cos PBQ. And you can already see how we're getting close to what the question's asking for. We have cos PBQ and we have 200, and those are both in the question. So we've deduced that from this up here. However, we know that we need to know what A is now, because A is not in this equation. There's an x squared, which is a hint. The x squared, where else have they mentioned this x squared? Right here. And we know that these both share the same side. So we're now going to look at this one, because they both share this side. So if I can find what this is, I know what this is. They're both the same. So let's look at this triangle up here. And let's do the exact same thing. Let's apply that exact same formula. I'm just going to draw a line straight down to separate the two out. Let me just draw a straight line down. And now look at cos. So I'll just write that here. This is triangle A, B, C. And this was triangle P, B, Q. So that'll be A squared. So let's label the sides again. So we can use the same A, because that's the angle. So that must be capital A. The side opposite will be A. This can be B. I should probably use a slightly different color so it's not confusing. So that's going to be A, because that's the only angle we have. So this must be A, this is B, and this is C. So if I now go down here, so that's going to be A squared is equal to B squared, which is X, plus C squared, which is X, minus 2BC, which is 2X squared, and cos 30, so we know what cos is. So now we can simplify this a bit. So A squared is equal to 2X squared plus minus 2X squared cos 30. Now we know what A squared here is, and we know it's the exact same as what A squared here is. So let me just highlight that. The fact that this and this are both the exact same length, because we deducted that from this bit here. So they're both equal to each other. So we can now come down here and write 2 x squared minus, I'm just copying the equation for ABC that we got for A, cos 30 is equal to, I'm going to copy what's above, 200 cos PBQ. Right, and we can already see how that's looking very close to the proof. We've now also got an x squared. So now what can I do? So let's look at both sides of the equation. We want to get cos PBQ on its own. We know that because we can see that from up here. I want to get this on its own. So I want to rearrange this equation to make that the subject. Let me just rub that off. So first let's just factorize a bit. So this can be 2x squared. So that will be 1 minus cos 30. which is equal to 200. So we can also move this 200 over now to that side, so that'll become minus 200 is equal to minus 200 cos PBQ. We can divide each side by minus 200 to get rid of this 200 here. So that then becomes, so that'll become 200 minus, I've just moved that over, so this will become a positive because we're dividing by a negative 200. So that'll become, actually I'll write this out so it's not too confusing. So that will become 2x squared bracket 1 minus cos 30 minus 200. Well, we're dividing the whole thing by 200, but we can pretty much imagine it like this. But it's the exact same as doing that, dividing the whole thing by 200, and that's equal to now cos PBQ. And we can now see that these two and this can be simplified, so that would become x squared bracket 1 minus cos 30 minus 1, and this will still have 100 underneath it, because 2 and 100, 2 divided by 200 is 100 underneath, and 200 by 200 is negative 1, is equal to cos PBQ. And now you can see we are very close to the answer. So we've got 100 in the denominator, we've got the 1 minus, and we can write that the other way around. So I'm just going to scroll down a little bit. Actually, I can just highlight this and make it a little bit smaller, so I've got a bit more space to work with. There we go. So if I push that up there, go back and grab my pen. So this can now be written as 1 minus cos 30. X squared can go outside, all over 100 is equal to cos PBQ. And hopefully you can see that it's getting very close to the final answer. Now cos 30 is root 3 over 2. So we can do 1 minus root 3 over 2. That's what cos 30 is. And all I'm doing is looking at it in a bracket. And if you do 1 minus root 3 over 2, you'll end up with 2 minus root 3. So that then becomes 1 minus 2 minus root 3 x squared all over 100 is equal to cos PBQ. And what are we missing? So I'm just missing this 200. So let's just have a look. This is also the benefit of me doing it live, is that, you can see sort of mistakes happen in action. So let's have a look at what I've done. So I've divided that by that, and then that by that, and then I've left with this. Right, and then I've made that a 1. So at what point? So I moved that over, divided each side by minus 200, that became minus 100, and I turned that into 100 from there, and then interesting. What have I done? So that, cool. Actually, what have I done here? So 1 minus root 3 over 2, what does this actually become? So if I think I might have made a mistake here. So if I times this by 2, times the bottom by 2, so that's 2 over 2 minus root 3 over 2, which becomes 2 minus root 3. Oh, there we go, that's the mistake. So this is actually root 2, this is actually 2 minus root 3 over 2. So I'm just going to scroll down a little bit here, and I'm going to copy, so I'm just going to rub this bit out. Everything else is fine. So that 100 there is perfect, that's fine. So what I'm now going to do is move down here. So actually this becomes 1 minus 2 minus root 3 over 2 x squared all over 100 is equal to cos PBQ. And where I made a mistake was, I forgot this 2, so this 2 can now come out, so that becomes 1 bracket, a half, 2 minus root 3 x squared all over 100 is equal to cos PBQ, and if you do a half and 100, that becomes 1 bracket, 2 minus root 3 all over 200 x squared is equal to cos PBQ. So I hope you enjoyed this video. If you did, please don't forget to like, share and subscribe, and stay tuned for more.